Hi students, welcome to the session on magnetic field due to infinite current sheet using Ampere Circuital law. What we are going to do here in this video is we are going to find magnetic field generated because of the current flowing through this infinite sheet. That's what our aim, right? So this is a infinite sheet, this white color sheet that I kept in the XY plane. Right, simply assume that you have kept one sheet in the your floor of the house, right? So this is what we have kept. Your building, your room height is z-axis. One direction is x-axis and another one direction is y-axis. We kept this sheet in the floor like that. You assume that. Fine. Here, so xy plane it is there, or z is equal to 0 plane. That means there is no z value. Here z is always 0. That's why it is called xy plane. Okay, then what we have to do next thing is here the current flowing through this sheet is uniform surface current density. Surface current it is flowing whose value is k vector, right? We know what is the meaning of k vector that we dealt in the Majeeth video. If you have any doubt, please refer my video on Majeeth. So any vector we can represent, surface current is represented by k vector. So any vector can be written in terms of its magnitude. So magnitude of k vector is k, and direction. In which direction the current is flowing? The current is flowing in y direction. So we can write unit vector is along y direction. Ky ampere per meter. Right? This is the one thing we have to remember. Next, what is the thing we have to learn is, so now I want to use Ampere Circuital law. So Ampere Circuital law, by using Ampere Circuital law only, I am going to find magnetic field generated. So whenever I want to use Ampere Circuital law, I have to choose Amperian loop. So Amperian loop I have to choose. How to choose Amperian loop? This also I dealt in the Ampere Circuital law video. Please refer that. So how to choose this Amperian loop should be symmetry with respect to the current carrying surface or sheet or conductor. So here what I am going to do, let me consider this sheet contain a many filament like this. If you add all the filaments, it ultimately we get total sheet like that fully. I didn't draw properly. If you take all the sheet closer, it is a filament, right? So a filament. You consider this sheet contains infinite number of filaments. Any sheet contains infinite number of filaments. So I am going to find what is the magnetic field generated by this filament above the sheet or below the sheet. That means the sheet is in floor means you want to find in the ceiling of above means above the floor here or below the floor here or anywhere below the sheet, or as per your room it is ground, it is above the ground, it is below the ground, like that you assume. So with this assumption, now what type of Amperian loop we have to choose? The sheet is containing filament. I want to find what is the magnetic field produced by individual filament and find the collective magnetic field. So first I have to find what is the magnetic field produced by this filament. Which shape is symmetry with respect to this filament shape? A line, sorry, a rectangle. This rectangle is symmetry with respect to this filament. Why? If you reduce the size of the rectangle to 0, 0 means not 0, very, very small. If you reduce the width of the rectangle, it will become a point. Like that, if you reduce the width of the rectangle, it will become a point. Ultimately, all the points will be leading to line. So, rectangle is symmetry with respect to filament. So, I choose rectangular loop as an Amperian loop. Right? So, my sheet has filament like this. This is also one of the filament. So as per Ampere Circuital law, your loop should cover the source, right? So that's what we are keeping my rectangular loop perpendicular to the sheet. One half of the loop is above the ground and another half of the loop is below the sheet, right? So the loop is 1, 2, 3, 4, rectangular loop 1, 2, 3, 4. Okay, fine, right? So now we can apply Ampere Circuital law and find the answer. Right, before that we have to see some important points to be noted. What is that is, since from Biot-Savart law we know that current and magnetic field cannot be in same direction. Right, if you have any doubt, please refer my video on Biot-Savart law. Current and magnetic field cannot be in same direction. You see, current is flowing in y direction, so there won't be any magnetic field component along y direction. So because current is in y direction, so Hy is 0. So the magnetic field, y component of magnetic field is 0 because K flows in y direction. As per Biot-Savart law, current K flows in y direction. Current and magnetic field cannot be in same direction. Right? Second thing, the Z component of magnetic field is also 0 because the sheet is in y direction. Sorry, sheet is in xy plane. We know that. We have kept the sheet in xy plane. So what happens if a magnetic field produced, if the sheet produces magnetic field here, it will also produce the same magnetic field here. So this positive and this negative, this is a positive magnetic field, this is a negative magnetic field. They will cancel each other because they are at the same height above the ground and below the ground. So Z component of the magnetic field is also absent. So what is that? Only X component is present. So X component of magnetic field is present. That can be written as H vector. So H vector is a magnetic field vector. It has contained only X component. So X component will be in X direction. Let us assume any vector can be represented in terms of its magnitude. Let us assume the magnitude of H along X direction is H naught. Direction is given by Ax. Similarly, what is that? It is for Z is greater than 0. Why? It will produce above the ground. The sheet will produce magnetic field above the ground or below the ground. So above the ground Z is greater than 0. So in that X component is HOAX. Below the ground, let us assume it is minus, opposite, since Z is greater. So sheet is here above the ground. This is Z direction, positive Z. This is minus Z. So only X component is present. The X component of magnetic field is given by HOAX in the positive Z direction. In the negative Z direction, it is minus, because we are going to find, this is a sheet, we are going to find magnetic field either above the sheet or anywhere in this here or below the sheet. So above the sheet, X component has positive value. Below the sheet, it's negative. As usual, we know about that. Okay, now we apply all these rules to find the magnetic field. So what we are going to do, we know H dot dl. This is Amperian loop 1, 2, 3, 4. So instead of taking a collective integral, I take a line integral from 1 to 2. Instead of loop, I take each line. Then 2 to 3, H dot dl. Then 3 to 4, H dot dl. Plus 4 to 1. Instead of loop, I segment loop into 4 line segment. So H dot dl. Okay. Right. So in 1 to 2, what is the magnetic field? What is the length? We will see. H is magnetic field, dl is the length. You see in the loop 1 to 2. This is 1 to 2. Here we can see that it is perpendicular to the sheet. That means it is parallel to Z axis. So it is having a Z component of magnetic field. But a Z component of magnetic field is 0. So here in from 1 to 2 here, the magnetic field is 0. And you see the arrow mark is going downwards. So length is going towards negative of, so the length is a here, so since it is going downwards it is minus a. So what I am going to write is, instead of 1 to 2, my value is here 1 to 2 means it is z component of h, so z component of h is 0, dl is minus a, because loop goes from, it is like this, no, I draw here itself, right? This is our loop, 1 2 3 4, right? This is in z direction, right? This is along x direction. Yeah, suppose if you draw in 2 dimension, it will be like this. This is in z direction, this is in x direction, right? Next, plus 2 to 3. 2 to 3, you see, from 2 to 3 you can see that in the loop the length dl is going along minus x. This is plus x, but arrow is going opposite to plus x. You see the arrow here, this arrow mark, this is arrow, this is going opposite, because x is in this direction, opposite in this direction. So dl is minus b, because negative, it is going towards top side, so it is minus b, and it is along x axis. So moreover it is below the sheet, that's what I have mentioned it dot. Below the sheet, x component of magnetic field is, you see, below the sheet x component of the magnetic field is minus h naught, because it is less than, z is less than 0. So you see here z is positive, the loop is below the sheet, it is minus, so minus z naught, and the length is minus b. So h is minus h naught and length is minus b. From 3 to 4 again, 3 to 4 again the loop is in parallel to the z axis, so there is no z component, so h 0, but dl is positive direction, so positive a. This is a means this is also a. So what is the thing? So 0, anyway it is 0 only, just for 0 comma a, 0 into a. Then 4 to 1, you see 4 to 1, it is above the ground. 4 to 1 is above the ground, and it is along the positive x direction. Loop is in this direction, is x also going in this direction. Positive x direction, what is magnetic field? Hx. The length is b, because it is in the positive x direction. What is the length of the loop? It is b only. So above the ground, 4 to 1 is above the ground. Above the ground, z is greater than 0. Value is h naught. So h naught, right? So h naught into b. You may ask, sir, this is the dl, this is vector. Now how can you say? You see h naught, in which direction the unit vector is there? It is 4 to 1, that is positive x direction. The length is b, vector is in which direction the length is going? Ax dot ax 1 only, so it is h naught b. Similarly here also it is going minus h naught ax, this is minus b ax, the ax dot ax h naught b only. So that's what I have done simply. Okay, so now we got all the points. Now if we simplify, we get it 2 h naught b. This is what your h dot dl. Right? This is my equation number 1. Right hand side is I enclosed. I enclosed we want. We know K is a surface current. Right? Surface current is given by K. What is that? K is current per area. So current per length. That is what surface current. We know. K is given by current per length. Ampere per meter. If you have any doubt, please refer my video on Majeeth law. So current is I. Length is B. Because in the Amperian loop, current flowing through the Ampere loop, you see what is the length of the loop? B. Right? So length of the loop is B. So what is that? K is equal to IB. This is K is nothing but surface current. But for Ampere circuital law, I need current only, line current. So K is equal to IB. Therefore, current is equal to K into B. Fine. So K, which is direction? In the y direction it is flowing. So I is equal to KYB. Now as per Ampere Circuital, H dot dl is equal to I enclosed. H dot dl, this is 1 is equal to 2, we have to equate as per Ampere Circuital law. So H dot dl is equal to 2 H naught B. I enclosed is KYB. So BB cancel. This implies H is equal to, H naught is equal to 1 by 2 Ky. This is the magnitude of the magnetic field produced by infinite sheet, right? So in with vector form, how can we write? H vector is equal to 1 by 2 Ky. This magnetic field has only x component, so we have x direction, Ax. Fine. So this is above sheet. Z is greater than 0, right? Then you see below the sheet minus 1 by 2 Ky. Below means minus x direction, so Z is less than 0. So from this, this is the magnetic field produced by infinite sheet. From this, what we are understanding? So collectively we can write H is equal to 1 by 2 K vector into An cap in general. Suppose if our sheet is in yx plane or xz plane, the answer will be in general like that. We have to shift the answer. Why? How can I write like this? See, if your sheet is there, it is like kept like this. N cap, An cap will be positive here above the sheet. That's what your An cap. Below the sheet, it will go like this. So it will be minus An cap or minus Ax, right? So that's what together I have written as this one, right? So this is a magnetic field produced by infinite current sheet. Here we have kept sheet in the xy plane, right, and found a magnetic field in the above the sheet and below the sheet. Like for this, the problem answer is like this. Similarly, you can keep your sheet in the yz plane and derive the equation for this. So if you do all the things in general, we can write k cross a power an cap, right? So this is what magnetic field generated due to the sheet of charge. So unit vector an is always perpendicular to the sheet, perpendicular to the plane of sheet. Suppose if you kept your sheet like this, the unit vector will go positive an, this is negative an. This is what xz plane, it is y is equal to 0 plane, right? Like that you can kept and change the answer like this, right? So here you see the magnetic field is independent of distance. There is no r, there is no distance. It depends only on the surface current. So current produces magnetic field in the surface. Surface current produces in the sheet, right? So independent of independent of distance. We know as per Weier's-Savart law and infinite current carrying conductor, line current produces magnetic field. This is a sheet, so surface current produces magnetic field. That's very beautiful concept. This K is surface current. This is magnetic field. Since it is a sheet, surface current produces magnetic field, right? Similarly, for line current, in conductor we have studied H is equal to I by 2 pi r n cap. Here line current produces magnetic field. I hope you understand the concept very well. If you have any doubt, please ask me in comment section. I will clarify. Thank you.